Hello, everyone. So we are going to have another MATHCOUNTS national problem. So this was also a question that a couple people asked. So which is why I just want to take some time to see how we can do this at least. So what we have is like there's a value of m is a huge fraction, and when you round this number to the nearest integer and divide by 100, so what's the remainder? So it's not really obvious what kind of background is kind of being tested in this problem, but when we see the remainder, that looks like a modular stuff, especially when you are divided by power of 10. So that's good to kind of connect those. And also, we are trying to find the nearest integer, which looks like is rounding problem as well, which is gonna remind us the floor and I guess ceiling function. So, but the numbers are too big, so which is why I just want to do some sort of substitution before we kind of start with some values, right? So the 9 to the 200, and then this power is also power of the multiple of 200, which is kind of nice. So I will take the 9 to the 200, right, as equal to x. Okay, so if I do this, my 9 doesn't look like 9, but so this guy is 200 times 200, so then the numerator will be x to the 200, and divide this by x minus 2. But we don't really know how to deal with this either. So what we usually try to see if there's a way to kind of remove this denominator or write the numerator is lower than denominator, so we can kind of get that fraction will be something between 0 to 1. That is one main I guess approaches to deal with the rounding stuff. But the numerator is way bigger than denominator. We just need to deal with that, right? So we want to get this guy, 9 to the 200 minus 2 as a factor, or in this expression, x minus 2 as a factor. But if I want to get x minus 2 from the numerator, I should have something minus, which I don't have, right? So then I can just write this as x to the 200, and minus, since we want to get the x minus 2 as a factor, so I'm going to take the 2 to the 200 power. So at this point, this is difference of powers, right? So we know difference of cubes, difference of even 4th power, difference of square for sure, but this is the 200 power. So which is also good to kind of remember how to deal with those as well. But when we subtract this, I change the numerator. I cannot do that, so I had to add the same number as well. So 2 to the 200. And my numerator is that, and the denominator didn't change. So that's x minus 2. So you will see why I'm doing this in a second, if you didn't see, yeah. So if I split these two and this separately with this denominator, so you will get x to the 200 minus 2 to the 200 over x minus 2 plus 2 to the 200. This whole thing divided by x minus 2. So this is factorable, and the one factor is x minus 2. We just maybe can remember the factor theorem, or you can just kind of guess and then prove it. So the numerator will become just x minus 2 times. So if you want to get some other terms, but every other term that you are going to create should be eliminate each other, and then you are going to end up getting only these two terms when you multiply. So if you multiply x by something, you should get 200 power of x, which means x to the 199 has to be my first term, and I will get plus x to the 198. But I need to multiply that by 2 to the first power. Again, if you are not really sure how I'm getting these, I guess you want to review the taking the difference of huge exponent. So it's just not too complicated either. So you can just ask yourself, if I multiply x by, let's say, this number, that will be x to the 199 times 2. Why do I need 2? Because I need to multiply this by this. That will be negative 2 times x to the 199. So they has to be add up to 0. And then if you keep doing this, you will get the next term will be x to the 197 times 2 squared. And the power of the x will decrease while the 2's will increase. So you will just continue in this. I'm going to add 2 last terms. So the last term before the last term will be x to the first power times 2 to the, when you look at the power of the x and 2, they add up to 199. So this is 97 and like 2, that's 99. So that means 2 to the 198, right? And then the last sum should be x to the 0 and 2 to the 199. So I'm going to write 2 to 199. Okay, so this is them. And the denominator is just x minus 2. So I can just divide this whole thing by x minus 2 and cancel x minus 2. I don't want to write it. And that's the first part. And plus the second part is 2 to the 200 over x minus 2. But we do know x minus 2, x is 9 to the 200, right? So 9 to the 200 and minus x, minus 2. So let's remember the m is the integer that is the closest when you simplify this mass, right? But when I write this in terms of sum of the two fraction, I end up getting this. But since x is like 9 to the 200, so all of these terms are gonna be integer. Their sum is also integer, and this is the only one that will give us a fractional part. But when you look at this, like 9 to the 200 is a like big value, right? When you subtract 2, it doesn't make any huge difference. So when you look at the numerator, 2 to the 200, which means if I ignore this negative 2, that will be 2 over 9 to the 200 power. 2 over 9 is like almost 0.2. When you take the 200 power, that will be really close to 0. So when you take the, I would say the floor, because that's gonna be closest. So this fraction will be way smaller than half of 1, right? So which means if I kind of find the closest integer, then this guy will be like no value. So I'm gonna just remove that. So then the value of this number or this number will be, the closed integer will be whatever I get from this expression. So the question is, like we have x to the 199, which is like 9 to the 200. And I want to know what I get if I divide this by 100. So good news is, we do know like 9 and 100, because we are trying to divide by 100, is relatively prime. So what we are trying to do, so I'm gonna say this is the say k. So if I divide this by 100, which is gonna take the mod 100, and to see what we get as a remainder. So again, 9 and 100 is relatively prime, so we can use like Euler's like torsion function. So if you kind of don't know torsion function either, so it is something I'm going to add maybe some resource in the description you can take a look at. But the torsion function is basically when you have like you are trying to find the number of like number of divisor that is relatively prime to the any given numbers. For example, 100. So the way that we do, there are two main ways people use it, but this is what I like. We just take the prime factorization, and then the torsion function, we just kind of use this phi symbol of 100. The value of this is equal to, you take the primes with the largest exponent, which is 2 squared, and subtract one lower value of this. So this was 2, so that's subtract 1, and then the same thing with the 5. Again, this is one way we use the torsion function. That's going to be 4 minus 2, which is 2. 2 times 20 is 40. So meaning that when you have the 40, and since we have the 9 and 100 is relative prime, by the Euler's, like I will say, formula or relation or whatever statement, we can say, maybe I should remind that a bit. So if there is like two things, like a to the like Euler's of a function, so let's call this is like n. This is going to be congruent to 1 when you take any mod, I will say n. If a and n are relative prime. So in this case, n is 100 and a is 9, so they are relative prime, so which is why we are safe. So we can use Euler's formula. I think this is not equal, this is congruent. So that means 9 to the 40th power will actually give us 1 if you take mod 100. Okay, so that should be our first step. And which is gonna help because if you have 9 to the 40 power is 1, so x is like 99 to the 200 power. So any power of 1 will be 1, so which means x to 199, x to 198, x to 197. All the power of x will be just 1 anyway, because you're just taking power of 1. So then the question became this. So I'm gonna write in different color. So the question became 1 instead of 1 x to the 199, just 1. And this is going to be 1 times 2, which is 2 to the first power. And the next one is 2 to the second power. And if you keep doing this, right, then you will get 2 to the 198 and 2 to the 199. So the question is asking what this guy is congruent to. I'm going to say this is equal to y if you take mod 100. So this is the problem, mostly is part of the problem, because at this point, not maybe this right after this stuff. So you can add these as a geometric series if you add them. So the left side will be 2 to the 200 minus 1, which is what we are trying to get the remainder when you divide by 100. So that's mod 100. So if I can handle this 2 to the 200 power somehow, then the question is over, right? So to do so, since we are not allowed to use calculator, so I'll just kind of manually do it anyway. So I'll just start finding a pattern if there is. So by taking the power of 2, so that should be 2. I'm not gonna write mod 100, so I'm gonna just write 2 square is 4, and the third power is 8. So fourth power will be 16, and then fifth power is 32. 2 to the 6 would be 64, and 7th will be 128, but I will take the last 2 digits since we are taking mod 100. And then you got 8 power would be, so 56, and then 9th power would be 112, so we just take 12. So if I keep doing this until I see a pattern or just one, so that will be 24, and then 2 to the 11 is going to be 48, right? So I don't want to mess because it's kind of with tedious already. So we have 2 to the 11 power so far, so which looks like, I guess we are doing good. And then 2 to the 12 is 96. So I can take -4 and then square, that will be 2 to 24. So I probably can use that. But at the end, I kind of need to get 200 power, which is not the somehow power of 24, which is close, but it's not really helpful. So I'm going to just list them as anyway. So again, -4 might be useful. So 2 to the 13 is like twice of 96, which is 192. So you will just get 92 for 13 power. And if I get 14, so that should be like 84, right? And then 2 to the 15 is gonna be twice of 84, which is 168. So I'll take 68. And 2 to the 16, I hope I'm gonna get something nicer. So twice of these numbers will be 16. That's gonna be 36. 2 to the 17. I know that I will get a repetition at 24 because I get like 12. I mean 11. The 12 power was -4. When you square that, that will be 2 to 24 is 16, which is we had, which means at most 4 to 24, which looks like we are gonna repeat every 20 numbers. So which is why I am kind of hopeful. So that will give us like 72. And then 2 to the 18 is 144, which is 44. So 2 to the 19 is gonna be 88, and 2 to the 20, right? So we have twice of this will be 176, 2 to the 21, I believe. So that should be 152. So that's 52. So 2 to the 22 should be 104, which is 04. So again, I kind of see the pattern right now already. So we have 04, and then we got 2 to the 23, So that will be twice of this will be 0, 8, which is right there. So now we confirm that our pattern is actually consistent with 20. So that should be 16. So what I'm going to do, I'm going to take the 2 to the second power and 2 to the 22nd power. So based on that pattern, we kind of got, so 2 to the second power is congruent to 2 to the 22nd power. And this is going to be equal to 2 to the 42. Every 20 terms, you're going to repeat that. So if you keep doing this, or you can just divide 200 by like 20 and see, that will give us 2 to the 202 as well. So, or you can go with 82, 182, but 202 is really close. So what we do now, we just need two numbers backwards. So since the pattern is going to start at 22 in my like kind of case, I like to go two numbers backwards. So the previous number is 21st power is 52, which means this is going to be congruent to 2000, like 2 to the 2000, I mean 2 to the 201 is congruent to like 52. And if you go back one more, 2 to the 200 will be congruent to 76. So which is good, because if that is 76, we already know we were trying to find the 2 to the 200 minus 1, and this number is congruent to 76. So then the question will become 76 minus 1, which is 75, and that is my answer. So I hope that was clear. So if you have some other ways, especially for the last part, a bit better, maybe faster, a bit slicker than this, so let me know. But I think this is a reasonable work for the number 30. So if you can kind of do this a bit faster, I think it's not too bad problem for number 30. I'll see you in the next video.